Hello and welcome to our next webinar with the topic new fan coil actuators. Yeah, my name is Thorsten Reibel from ABB Stotz-Kontakt. I sit here together with Jürgen Schilder. As always, we will conduct the webinar together. Yeah, I will start right now with introduction into the topic fan coil units a bit. Of course, then we continue with our new family of fan coil actuators with all the features. All the news we have around these products. Yeah, and then Jürgen will continue with an introduction of the IBAS tool usage together with these new components, which are also supported by the IBAS tool. And yeah, if you have any questions, please give it to us in the chat room. You can write something. Here, as always, we try to answer immediately or latest at the end of our webinar. If not possible to answer right now, we will send you, of course, as always, the feedback email with a recorded file, with a presentation, and also with some open questions maybe we would like to answer then right now. As you know, at the end of the webinar, we will have a questionnaire with some questions around our topic from today, and so please answer these questions and complete the webinar this way. If you're not able to do this right now, we will send you also in the feedback email a reminder, and then you can do it also later on. Good. So let's start with our webinar today. New fan coil actuators FCA/S. So just a moment. So I have, at the beginning of two funny pictures of the principle of a fan coil unit. You see here two solutions based on a normal radiator with most probably hot water inside for heating and a fan. So you can see here the principle of a fan coil unit quite well. So we have any heat exchanger, and together with a fan we can blow out warm air, here in this case, into the room to heat up the room. Other more funny example here is an ice block together with a fan as well. So it's here made for cooling. So what do we need? We need any heat exchanger, any cold or warm water medium. Together with a motor and a fan, we can blow out cold or warm air into the room. And of course, we need somebody to control this. In this case, here persons. In our case, of course, with KNX, it will be our fan coil actuators. Yeah. Definition in some more, let me say, technical words. Terms are fan coil unit. That's one name which is very often used. Sometimes also blower convector. And yeah, fan coil devices are made for individual heating and cooling, or one of this, in a room. So it's room temperature control. So by means of a fan, the air will pass on low noise the heat exchanger in order to heat up or cool down the room temperature. So we need any element which has cold or warm water inside for heating or for cooling. But you will see some more details in the next slide. Yeah, what is prerequisite? You need, of course, cold or hot water to run such a system. So can be generated in the building itself with a central boiler, or also in some areas in the world for cold water, for chilled water. There are some district cooling units or buildings existing, supplying the buildings with chilled water then. Yeah, available are different types. On the left you see already some pictures of real components for ceiling mounting or wall mounting, for example. And we distinguish additionally also so-called 2, 3 and 4 piping systems. Has to do with a water supply, and we will see it in one of the next slides. But here, first of all, a general overview of a fan coil unit solution with many rooms in a building. And you see here a solution with central generation of cold and warm water in the building. Individual pipes for cooling and for heating will go into the rooms, to the local fan coil units, where you have these heat exchangers, a fan and so on inside, and together with a room temperature controller, of course, and shown here on the right side, a fan coil actuator. We have a very powerful room temperature control solution, both for heating and cooling available. If you look to the more detailed picture of a fan coil unit, you see here exactly this what we have seen before in more details. Our recuperator for heating and chiller for cooling. supplied by warm water in winter or by cold water in summer. And together with our valve control, that's what we are doing with our fan coil actuator, of course, and the fan operated via a motor, of course, in different speed, we can control the room temperature. So this is the main part. We need valve control and we need fan speed control, and then it's possible to run such a fan coil unit with our fan coil actuators. There are some additional features here visible on the slide. Electrical heater, an option if you have hardly heating necessary in your building due to the region where you are right now, then you can use also an electrical heater. We can control this via a separate switch actuator relay in our fan coil actuators, and together with your fan you can blow out warm air as well. And you see here FCAS, symbol for our fan coil actuators, we can use, of course, to control the unit. Later on we'll see also a solution with window contact connection, or a sensor for condensed water can be integrated as well, but will be shown later on a bit more detailed. These 2, 3 and 4 pipe system in the next slide as an overview. We have here a so-called 4 pipe system for fan coil unit. Means we have 4 individual pipes, 2 for cooling water or cold water and 2 for warm water, so we can supply independently, not in parallel of course, makes no sense, but in the right season we supply warm water and in summer cold water, and each circuit has individual valves. We can control with our fan coil actuator. The fan and the motor to blow out the air is the same. So a typical 4 pipe system, you can save 1 pipe by using a 3 pipe system, which has a common return line, so individual inputs as well with individual valves, but only 1 return line. And if you have, for example, only cooling or only heating necessary, you can use also such a 2 pipe system. You supply it only with cold water if you have cooling necessary, or only warm water if heating. But of course you can use it also for both. In winter you supply this 2 pipe system with warm water, and in summer with cold water. You change. It's also possible. So there are some options, and you see we need only 1 valve here in this case. All these things can be adjusted in the parameters of our application depending on the fan coil unit you are using. And some pictures of real components you have seen already in some slides before. Components, I don't want to go into details here. Wall-mounted or floor-mounted solution here, but also ceiling installation is possible. There are a lot of components on the market worldwide available, and so it's a real standard product in many regions and in many projects all over the world. Going a bit more in details, also together with other KNX devices, we have here an example of an office solution, where we have temperature control, of course, necessary. Let's assume we have both here, heating and cooling. You see here already one of our new fan coil actuators with the typical connections we need. Valve control, 2 different valves can be controlled. Our 3 relays to control the fan speed. Optional relay we have here to control, for example, an electrical heater. It's possible. And we have inputs, binary inputs, in this case for the window contact. And here a condensed water sensor, for example, which detects any condensed water in the system, which can be dangerous for the fan coil unit. Then it will be detected and the system can be shut down, for example. What we always need is a room thermostat based on KNX. This is a device to measure the temperature, to send out control values to the fan coil actuator, to control both the valve and the fan in the right way. And this is a typical solution we have. Optionally here a presence detector, which of course also can change the set point, for example, depending on presence, to save energy, for example. The same and very often in use in hotel rooms, typical solution in hotel rooms. These are rooms where you need a powerful cooling or heating solution, and also a very fast regulation is required. It's one of the advantages of a fan coil unit. Thanks to the fan or the blower inside, we can blow out the warm or the cold air, and heating up or cooling down is very fast, very quickly possible. and that's one of the reasons why this is very often in use in hotel rooms. But the same principle we have seen already before in the hotel solution. Sorry, in the office solution. Yeah, a bit technique regarding control, yeah, and also sending out or receiving control values from the room thermostat. What do we see here in this graph, in this diagram? On the x-axis, we see the room temperature. This, of course, can be changed or can be different in the room. And on the y-axis, the control value sent out by the room temperature controller. So what do we do in such a constellation with a fan coil unit and fan coil actuator? We program or adjust in the parameters set points. Typically a set point for heating and a set point for cooling. And in between there is a small range which can be different depending on the project, where you have neither heating nor cooling necessary, because you say, okay, it's not too warm, not too cold. I accept here a floating room temperature, slightly floating room temperature. But if it's getting hotter than 24 degrees, I have to start cooling. Or if I'm lower than 21 degrees in the room, I have to start heating. Means the room thermostat sends out a control value which increase. And depending on the control value, let's assume 40%, for example, the fan in the fan coil unit will be adjusted to a certain speed, in this case to speed 2. And 40% means also normally we open the valve 40%. Because we need, of course, also here in this case warm water in the system. So typically there is a linear relation between the control value and the position of the valve. But the fan speed is possible to be adjusted, can run in 3 different speeds. So we have to program thresholds, limits, where we jump from one level to a next level. And this is freely programmable. In this case, maybe we talk about 10% minimum control value to go at least to speed number 1. If you're higher than 30% or 25 or whatever percent, we go to speed 2. And over 60% control value, we go to speed 3. So depending on the demand, we also increase or decrease the speed of the fan, but only in steps possible. And in many cases, the control of the valve can be continuous control. You see later on the type of valves we can control. So there is a kind of linear relation between the control value and the position of the valve, but for the fan only in steps possible. So this will be the typical solution or situation. Important is again that you have here options, of course, to change the set point also during the operation later on, but typically we have a gap or dead zone between these 2 set points. Yeah, what kind of valves we can connect to our fan coil actuators? It's very important, depends on the fan coil unit used in your project. Very often and typically we have these thermoelectric valve drives, which is also available from ABB. So in our range available. Very simple, cost efficient and more or less maintenance free device to control the water flow in such a solution. Typically operated via 2-step control or pulse width modulation. Parameters in the room temperature controller. And we have a lot of components to run or to operate such an electrothermal valve drive. And here our new fan coil actuators, of course, as well. First of all, only the name here, but I come to some more details later. Yeah, furthermore, we have these so-called electromotor valve drives with a motor inside, and we need 2 contacts to open or to close the valve. For electrothermal valves, we need only 1 contact. So both are connectable to our components. And as before, and this is a bit more precise positioning possible, a bit faster reaction you have with electromotor valve drives. Only shown here but not highlighted are our KNX motor valve drive, normally not in use because it's independent solution, and as we have in our fan coil actuators always valve drive connection available, we use typically these non-KNX valve drives shown here, but in principle also possible to use. And last but not least, other type of valve drives controlled via an analog signal, 0 to 10 volt. Available as thermoelectric, in a thermoelectric version, but also in an electromotor version. So here again, the same principle like the other device before, but here we have a real motor. But control signal is always 0 to 10 volt. We need another output in our fan coil actuators, and of course also available, that exists also in some projects. It's another type of fan coil actuator, but you will see in the next slides. So these kind of valves, which are covering most of the market, can be connected. Yeah, before we come to the new device, just an overview of the existing fan coil actuators we have already. These are the four first ones here. Our room controller. This box here is available with fan coil control. The room master, typically for hotels. Then we have our earliest version of fan coil. It's not only an actuator but also a controller. Means you can connect only a temperature sensor here, and you have complete temperature control available. It's from the beginning still in our range, but not so often used anymore. And the blower actuator, relatively new. It's called blower actuator because it's mainly used only for running fan in different speeds, but as there's an additional output, you can also connect electrothermal valve drive. But be careful, only completely open or close, so we cannot modulate, we cannot position the valve. It's a, let me say, reduced solution for fan coil control, but in principle possible for some simple, let me say, applications. Yeah, and what do we phase out very soon? Our existing real, let's say, complete fan coil actuators, FCA-S11M, for electrothermal valve drives and motor valve drives. And this version is also existing for 0 to 10 volt valve, or was existing more or less. These two devices will be replaced by 4 new components, shown here, and you will see what's behind. So the other one is still existing, this will be phased out, this is new. So let's have a look to the next 2 slides. I start with the FCAS 1.1.x2. X stands for different versions. We have 2 here. And you have a look. You see already one without manual operation and one with manual operation. That's new. We hadn't fan coil actuators before without manual operation. Not correct. You had already a former version, but the 2 ones we phase out now, they had always a manual operation. So we have extended this here a bit. So successor of the FCAS11M, which is in one point different. It's smaller, the former version, 4 modules only. But the new ones have all 6 modules with, so they are a bit larger. Take care of it if you have this. If you think about any projects where you already planned maybe the former version of the FCAS11M, might be an issue to think about. Controllable are thermoelectric valve drives and motor valve drives. Version 2 as a third digit, 1.1.2 has manual operation, this one here, and 1.1.1.2 has no manual operation. That's the difference. Of course, there are some more difference in these components. Here already some features. We have 3 binary inputs, always now available. The FCAS11M had only 2 binary inputs. But binary inputs is not the right word. In principle, these are inputs usable for potential free contacts as binary inputs, but also for analog values. So we can connect temperature sensors here, which are analog signals, with analog signals, and PT100 or PT1000 or these KT, KTY temperature sensors to measure with a simple, maybe PT100, PT1000 sensor, the room temperature in the room. Maybe additionally to the necessary room thermostat for controlling necessary, or we use it only for temperature measurement and we use our room thermostat only for controlling. This solution is available in the application of the room thermostat, and you can decide also what to do. So it allows you to measure the temperature in the room at a more, let me say, convenient way, or at a point where it's more precise to measure than the location of the room thermostat, but you have now the option and you don't need any additional analog input anymore. And a further feature You know our IBAS tool, our additional service tool we have available for different devices, and also the new Fan Coil Actuators will be supported, or will support the IBAS tool, or will be supported by the IBAS tool. So you have some features, nice features shown later on by Jürgen to you. So the first two we have seen already, and the next ones are not really different at the first glance, but it's the successors. These are the successor of the FCAS 1221. The Fan Coil Actuator we had already, or we still have, with 0 to 10 volt output. So, other hardware necessary for controlling the valve on the upper left side, you will see it here. Again, without and with manual operation. The rest is the same as already shown or explained before. So 3 inputs, analog, digital signals can be processed, and the IBAS tool support. And all the other software functions I will show to you are also the same here for these devices. It's not different. The only difference is if you have no manual operation, you have no parameters for parameterizing the manual operation, of course. But the rest, the main part of the software, is for all 4 devices the same. So this one for 0 to 10 volt motor valve drives, 1, 2, X2, so 2 stands now for 0 to 10 volt valves, and 1 stands for electronic outputs to control electrothermal or motor valve drives. So 4 new components. Yeah, I think this one explained already the way how the type description is running here, and so it's explained here again. I can skip this, and here's some more technical details. We have 3 relay outputs for the fan with 6 ampere outputs as before. We have this additional switch actuator output, for example for electric reheater. The 3 inputs for digital or analog signals, and depending on the type here, electronic output and analog output for the valve. Now the rest is more or less some more details of the product. I will skip this as well here, and let's concentrate here next step on the connection diagram in some more details. You see here the component with electronic output, where you can connect either electrothermal valve drives, and then you have 4 outputs available. Remember here A, B, C, D, and later on we will see that we can also program and use these outputs completely independently. What does it mean? You will see later on in some more details. But if you use electromotor valve drives, where you need 2 contacts, then you can connect only, shown here in this picture, 2 motor valve drives. A, B, so 2 outputs for 1 motor valve drive, and C, D for the second one. Fan speed control via 3 relays as before. Electric heater can be connected here, and here our 3 inputs, analog and digital connections are possible. And the next device with a 0 to 10 volt is really not different. Only here you see 0 to 10 volt, 2 outputs left, because we need also here 2 connection terminals per signal, and so you can connect here 2 different valves via a 0 to 10 volt signal. Let's come now to the application and some more details. What is available? At the beginning I start with some features not completely new. Most of them are already existing in the momentary, let me say, components. I mentioned already we have a unified application for all 4 devices. Nothing different anymore except these manual operation parameters, but the key points of this application are the same. Start-up behavior and run-on behavior. Start-up behavior means if you switch on your room temperature control, you can decide in the parameters, shall it start maybe with level 3 for the fan, maximum cooling or ventilation for 5 minutes. This is adjustable. We had it already before. New is the run-on behavior. I explain later in a separate picture, and that's new and a nice feature. Very often required by our customers and now also available here in the software. All valves can be used either for heating, for cooling, very flexible. Also here a bit more information later, how it works, what is possible now. So minimum time in a level, what does it mean? You can decide that if you are running with level 1, minimum it should run 3 minutes before it's allowed to go speeds 2. And also here maybe 3 minutes minimum time. So it avoids a continuous change of the fan speed. Yeah? Adjustable in the parameters as before. Thresholds for switching to another level. Remember my diagram. Depending on control value, you can run or go to any fan speed, also parameterizable. So you decide when you jump from one speed to another, depending on the percentage of your control level. And in order to have not all the time switching again, you can also program hysteresis. Let me say capability here, and also a typical solution for thresholds you find in many other devices. Then we have some additional features like limitation of fan stage in automatic mode. Automatic mode means the room temperature controller is controlling the speed and the position of the valve, and we can say, okay, if the fan is running in speed 3 in automatic mode due to the big temperature difference, we can also limit this maybe during the night mode in a room just to reduce the noise, for example. So it's not possible due to this limitation to go to speed 3. Furthermore, we have so-called forced operation of fan stage possible. What does it mean? We can bring the fan into a forced position, level 1, level 2 also off due to any reason. And this can be done both in the automatic mode and direct mode. Direct mode is nothing else but operating manually via local push button the fan speed. So you override the automatic mode, the room temperature controller. Also here are options regarding fixed levels available. Status messages, neither new for all these situations or actions in your fan coil unit. Fan stage, for example, is what is the position of the valve? Is there any fault in any channel? All these things can be done. And last but not least here, monitoring of the room temperature controller. So we can do the following, that we monitor the room temperature controller this way, that we expect in a certain period, a certain time, always control values by the room temperature controller. If we do not receive this, we as a fan coil actuator, then we go to any fixed position with our fan and our valve. So we have at least a safe, let me say, situation, though the room temperature controller is not working maybe anymore. So some new features already, at least with some words explained, but more details later. What else do we have? Characteristic curve adjustment. I explain another slide. What does it mean? Neither new. Valve purge. So maybe in any period where you have neither heating nor cooling, means no valve operation necessary. Then you can also, let me say, activate or run the valve maybe every week, just to keep it running mechanically, so nothing happens, so it's does not get stuck due to not existing operation. So we call it valve purge. Can be activated via a telegram or in automatic mode. Every week or every 2 weeks you can adjust this. Also, valves can be put into, let me say, a forced position independent of our control values. We also can block the valves due to any situation. So all these things are possible. What is new? Fan outputs, the 3 relays, can be used also as conventional switch outputs if you want. So if you don't need fan speed control, only valve control, you can use this as normal switch actuators. The same we have already in the Room Master, if you remember. So there it was also possible. Now here also in these new fan coil actuators. We have one additional relay. With the green lever means highest performance up to 20 ampere to operate anything whatever you want, typically this electrical heater. As mentioned, the inputs can be used for measuring analog values, temperature values. Also here we have typical parameters you will find in analog inputs. For example, we can program thresholds, 2 thresholds here. And also filtering is possible, means out of a certain number of measurements, we create a mean value to filter out any wrong measured values, for example, and also hysteresis function with the thresholds are possible. And here the type of fan, neither new but very important, can be adjusted, change over switch or step switch. What does it mean? have a look to the next slide. Depending on the fan coil unit you are using, there are two different ways to control the fan speed. Okay, we have 3 relays. But how to control the relays for the different speeds? 2 options. Changeover switch, the solution you see here, and have a look to the 3 relays we are using depending on the speed of the fan. If we need speed 1, we close the first relay to control speed 1, no problem. If we need speed 2, we first of all open the relay for speed 1 and some milliseconds later we close relay number 2 for speed 2. And the same for speed 3. So never 2 relays are closed at the same time, only one after another. Changeover switch, standard more or less, is also the default parameterization in the application of the fan coil actuators, but there's also something like this on the market. Fan speed control via step switch. The same principle for speed number 1, we have to close the first relay. But if you have to go to speed 2, we additionally close relay number 2. Means relay 1 for speed 1 stays closed, will be not opened. The same for speed 3, so all 3 relays are now closed. Other type of motor, other type of control, but adjustable in the parameters. Of course, you have to know which one is existing in your project, and you have to adjust to parameterize the right one. So default is the least dangerous one. Nothing can happen if you have a wrong motor connected. If you use this one, you should be sure that you have also this kind of motor connected. Otherwise, you can destroy the motor behind. Not new, but just a reminder. It's important to keep it in mind. Yeah, I mentioned already direct mode and automatic mode. Direct mode means I have maybe any local push button with rockers to go up and down to different speeds. So I press on the left side going down with the speed, and on the right side of the rocker to go up. So I need only one rocker, but you can also do the following to go directly to any speeds. Maybe you have 2 rockers off, speed 1, 2, 3. You need 4, let me say, buttons, and you can jump directly to any speed. Both are possible. And if you have automatic mode, means the room temperature controller is responsible to run everything. The control value will be sent out, and depending on your value, as already mentioned, you have different fan speeds and different positions of the valve. Let's come now to some nice new features, partly already mentioned, but not all. And here are some more, let me say, pictures, also screenshots from the ETS. By the way, I have used already ETS 5 now. Looks a bit different, but it's the same, let me say, information. So, independent valve outputs, individually programmable. We have, here in this case, FCAS 1122, 4 electronic outputs, you see it here, A, B, C, D, to control either electrothermal valve drives or motor valve drives. And here a constellation we can program now, together with these new components, we couldn't program before. Let's have a look. AB is programmed for controlling electromotor valve drives. You see it here in this communication object, valve AB. Control value cooling for a fan coil unit in room 1 for cooling. So here a group address will be assigned from the control value of the room thermostat. We have to control also the fan. Independent communication object, control value for fan, outputs EFG, gets the same group address. It's for cooling room 1 fan coil, means this belongs together. It's one fan coil unit. We have in the same room on channel C another electrothermal valve here with radiators behind for heating, independent of our fan coil unit. So we need an additional valve output for heating, but we don't need any fan in this case because it's a simple radiator for heating. Channel D is left. How to use? If you want, it's an independent output. You control in another room the radiator, means you need only valve control. So here another control value of another room thermostat in another room will be assigned. So we are very flexible. This was not possible before. with the former versions, and so in some cases you don't lose any outputs here anymore. The same here, an example for the Fan Coil Actuator with 0 to 10 volt. I have also made here an example. So we control, if we have only two valves left, valve A, output A is one output, and valve C is the second output for 0 to 10 volt. We have only two left. We have again our fan with individual communication object for control value. Now I create a solution here. Again, room 1, cooling via fan coil unit, the same group address for these belongs together. And valve C, again another room with 0 to 10 volt valve for heating, maybe only radiator, whatever you want, and an independent group address, of course. So, some more flexibility now, thanks to the adapted application we have. What else is interesting? Automatic adjustment of the valve drive. Valid for the FCAS 11X2 with motor valve drives, means with electronic outputs. And it's for the Jürgen just gave me a hint, but it's correctly described here. It's for the motor valve drive with electronic outputs. In such a situation, you can have the following. If you don't run to close position, normally you have only operation over 0, means in the middle, then this motor valve drive becomes unprecise, because you never reach the 0 position. And what can you do right now? It's after a certain number of, let me say, operations, receiving of the control value, you can say, okay, I go to 0 in between, once at least, before I take over the control value again. It leads to a more precise, let me say, positioning. A feature here in the Fan Coil Actuators. Binary inputs, again, not binary inputs, but inputs itself. If you use it as binary inputs, we have more options now regarding the software. Very similar to the classical inputs you know from the Room Master or from the binary inputs itself. What is possible now? More functions, sending up to 3 group addresses possible. You know this from other devices, so some more flexibility to assign different components. Sending of values is now possible. We can distinguish between short and long operation. And now also possible to have internal connections between an input and outputs you have in the same device. Which are these outputs? Normally output H only, which is a complete extra output, you know. But also output E, F and G, normally for fan speed control, can be assigned to the inputs, also can be assigned to an input via direct connection, if you use these output not for fan speed control. Is also possible. Either here similar to the Room Master. This I just mentioned here already, still described again. Fan outputs can be used as independent switching outputs. You see one parameter here, output E, F, G, enable as fan, standard, but also enable as switch actuators, if you want. And last but not least, here this very interesting parameter, new parameter, run-on behavior. It's together with the start-up behavior, one parameter block. Let me explain here. Start-up behavior is not new. Allows you, if you start the room temperature control in your room, to run at a certain speed level, fan speed level, for a certain time. So before the control value is overwriting this, you have this fixed operation of the fan speed, and then of course after, in this case, 5 seconds only here, it will go to the right level depending on the control value. Not new. Makes sense for fast ventilation or fast cooling down of a room if necessary. New is this run-on behavior. You can activate the parameters, and then you have 3 times available for the 3 speeds with the following background. If you are in speed 3, And due to any reason, control value says no, speed 2 is now enough, go down. Then in this case, it will run still 20 seconds in speed 3 before it goes to speed 2. So it's a delay in function or in reaction, but intentionally because we have programmed this here. So though the command says go to a lower speed, it stays still for this time in this speed. Interesting if you have speed 1 active and you would like to switch off the fan. Normally you send control value 0, or you go to your push button and switch off the fan will go off. But if you have a time programmed here, and it's again 20 seconds, it will run another 20 seconds in speed 1. For example, to avoid any water condensation in your system. So this was very often required if people said, okay, if you switch off the fan or the fan coil unit, it should not go off immediately, especially if you're on speed 1. Not off because we need to run on time. And is this adjustable? And up to now it was not adjustable, but here now available. So you can also enable and disable this behavior via a separate communication object. So if you don't need this, it's also possible to disable via a telegram, or you enable it if it's really necessary. We call it run-on behavior. Good. Yeah, and this valve curve adjustment, it was either existing in the former versions. Just some words around this. Here you see a diagram, control value or position of the valve depending on the control value. And if you see our FCA as our classical fan coil actuator, also new ones, there's a linear relation. Means if I have any control value, maybe 50%, the valve will be opened as well 50%. And you see here from our blower actuator, I mentioned already that it's possible to control also valves, but here in a very simple way only. Any control value greater than 0 leads to complete opening of the valve behind, because there's only a relay behind and no modulation, no positioning possible. But here, for more precise and sophisticated solution, you always would like to position the valve in the right way. Possible. And this curve, this linear curve, is standard, but can be adapted to the following way. Here's 2 examples. In this example, I say, no, I don't want to have a linear relation, at least at the beginning. In this case, if the control value is below 20%, I don't want to open the valve. No cooling, no heating, only ventilation. Because this means already level 1. So I block valve operation in the lower level here of the control value. Here vice versa. I always start with minimum 20% opening of the valve. Minimum, less is not possible. Because any low position of the valve leads to any noise, water flow noise. So if I open at 20%, no noise anymore, and this is more convenient. You have this option by this characteristic curve adjustment. Very simple. You have value pairs available where you adjust a different curve. So it's simply or very simple in the parameters possible. Special solution, but available. Not new again, but I would like to mention this here finally. Yeah, and coming back to the hardware a bit, to the manual operation. Yeah, similar to all these manual operations you know already from our KNX devices. We have this button with this hand symbol. You press this button until the LED goes on here on the left. Activating of manual mode or direct manual mode is not then possible or is then active. And with all these buttons you can operate all the outputs, and here in this case also the inputs directly. So here example with 0 to 10 volt valve outputs, opening, closing of valve A, 2 buttons, the same for valve C, and the LED over there shows opening of the valve. You can operate the fan speed, E, F, G with the 3 relays, and the 3 binary inputs as well. Plus H is the additional relay output. You can operate it here via the button, but as it is also available in direct mode, let's say via operating the lever of the relay. You can go also here with your screwdriver and operate it mechanically. So, standard way of manual operation. The same here for the solution with the electronic outputs. Then you have here A, B, C, D available, 4 buttons to open or to close, and 4 LEDs on top. But the rest is the same. So if you press on A, then LED will light it up and indicating opening of the valve will be actuated. Okay, let's come to the end of my part, at least slowly. Here the overview of all our HVAC components, not only related to fan coil unit control. You might remember this picture from other presentations. Here our new fan coil actuators, but to highlight all devices which have to do directly with fan coil unit control. I go to the next slide and you see here there are some devices. The Room Master family, room controller, the oldest version of our fan coil, in this case also controller, FCS 1.1. Our blower actuators, 1-fold, 2-fold. And now here, of course, let's say a family of our, let me say, mainly used fan coil actuators, I think, in future, with all these options you have seen already or heard from my side already. Market introduction of the new 4 components. We are really on time with our webinar today, or this time. Market launch will be next week, so beginning of next week, or beginning of May, and you will get, of course, some more detailed information then, as always. So more or less everything is ready, and you can immediately start to use this product. If you have still some project with the former fan coil actuators, still something available. But if you have any projects maybe with a lot of devices and you need still the old or still existing version, due to any reason, please inform us that we can plan accordingly and in order to have no delivery problems. You have seen technically we are on a higher level now. One challenge might be the size of the device. Remember, the fan coil actuator FCA is 1.1M, only 4 modules width. All the new ones, 6 modules. This is a difference, of course, has to do with technical situation with connection terminals, which are bigger now. Also one advantage compared with the FCA as 1.1. So more size, more space necessary. Here you see the overview again of the old devices, more or less old devices which will be discontinued, and the new components. And I think my last slide before Jürgen continues with the IBAS tool functionality, maybe the most important slide I showed to you today. And if you keep this in mind, I'm already happy. And what is exactly new with the new fan coil actuators? I had tried to summarize here the main features. Run-on behavior, remember. New software feature to keep the fan running, though control value goes to 0. The inputs, binary inputs, have extended functionality, like standard inputs. You expect normally from the inputs. So gives you also more options. You can use inputs also for analog measurement, temperature measurement with PT100, PT1000. So for more precise temperature measurement in the room. Independent of the room temperature controller. The valve outputs, these individually programmable with all these options I have shown to you a bit in the slides, in my last slides. So also request from the market to have some more features and flexibility here is covered with this solution. Fan outputs, not only for fan speed control, but also programmable as normal outputs for any purpose. If you see this, maybe it reminds you of the Room Master, because there's also something like this available. You can also maybe call our new fan coil actuators as a small Room Master version. So similar principle, let's say. And then remember, we have now also without manual operation components, which are of course less in costs compared with the versions with menu operation. I can give you already the euro list prices. Manual operation is the same price level as before, 343 euros, so no difference, but more power, more performance, and the components without manual operation 288 euros list price. So it's of course less. Universal head screw terminals. What does it mean? All these connection terminals are now on this level you expect from all or see in all our devices. The FCA S11M, the smaller one, was still with the smaller connection terminal, so it's also now in the standard version available. Yeah, and coming now to the final point, IBUS tool support. Remember this from many other devices. Of course, these new Fan Coil Actuators will be supported by the IBUS tool, and that's now Jürgen's part. And just a moment, Jürgen will come over now and show you a bit what is possible in the IBUS tool together with our new Fan Coil Actuators. Just a moment, please.
Hello and a warm welcome from my side. My name is Jürgen Schilder and I introduce you the new IBUS tool. This new version 1.9.2.0 now supports the new generation of our 4 Fan Coil Actuators. However, these screenshots now are taken by a pre-version of this IBUS tool, not a final version you can download from our website. Later you will see there are some words or English translations are not correct, so never mind, this is a pre-version of the IBUS tool. Okay, let's start the IBUS tool. The IBUS tool runs or works independent the ETS and helps you, system integrator or the electricians, to test the parameter settings or for commissioning or for the first fast diagnostic. So now let's start this IBUS tool. The IBUS tool runs on a standard PC or on your laptop. So we connect at first to a device. So let's start here. We press the button connect. The first step is we have to do the settings in our ETS and program the individual or so-called physical address of a KNX device and download the ETS application. Afterwards, we recommend to close the ETS and start the IBUS tool, because the ETS and the IBUS tool, they have bus access via the same Falcon driver, and that's why it makes sense to close one software and then start the other one. So now we need here the individual address of our Fan Coil Actuator. So please enter here in this field physical address or individual address, the address of our Fan Coil Actuator. In my example, it's the address 1150. And the next step, we have to select the interface, how we want to communicate via IP, for example, IP routing, IP interface, or here the standard communication like USB. And the next step, we press here the button connect, and then the IBUS tool builds up a communication between the IBUS tool and our Fan Coil Actuator, point-to-point communication. Now, if you don't know the individual address of your device, then you can press the programming button on your KNX device and start here the scan mode. And then the IBUS tool is looking for a device which is in the programming mode. Okay, but we know the address of our device, and then we press the button connect, and then the IBUS tool builds up this communication. It will last some seconds because the IBUS tool reads out the complete configuration of our Fan Coil Actuator. So now the communication is done. We can see here in an easy kind of visualization all our outputs and inputs of the Fan Coil Actuator. So the next step is, for example, here to use the so-called help file. So for more information you can press here the button help, and then here on the right side our help menu or help file appears, and you see here the description of all our parameters or of all our features here. So if you want to hide the help menus, and please press here on the button help again. So you can also zoom in or zoom out via the slider here on the bottom. You can zoom in, or when you shift here the slider to left, and then you can zoom out. So you can change like you want, or depending on the size of your screen, here the view of the Fan Coil Actuator. Now I'm here in my default view, so I can see all my settings here. So now if you want to have if you want to send commands to the fan coil actuator, then you have to go to the so-called configuration mode. At the moment we are in a so-called display mode. We see only status messages, but we can send no commands. So to send the command, then press here on the button select configuration mode, and then a window information pops up, gives you the information, yes, you want to send commands, click on the button OK, and then we are now in the configuration mode. We can see status messages and we can send commands. So let me start here with the first output, the output A of my thermoelectric valve. You see here all the parameterized settings which we have made, or which I have made in my ETS project. So for example, I can see here the information, the control type, that is here continuous. Yeah, the valve, the output A receives the control value as a 1 byte. It is parameterized as a heating valve. Yeah, I have also activated the monitoring, the cyclical monitoring of my control value. Yeah, and so here you can see all your maybe parameterized functions. Yeah, the safety is enabled. Additionally, how I use my safety functions, like here the safety function of my priority 1 is used for blocking, but it is not active. That's why this one here is gray. Now when the priority 1 is active, and then this LED becomes red. The safety priority 2, for example, is used as a forced operation, but at the moment is also not active. That's why the LED here is also gray and not red. Safety priority 3 is not parameterized. That's why we can see here the word inactive. Additionally, I have also the function purge and the characteristic curve adjustment also enabled. That's why we can see here a green LED. Now when we want to send a command like the control value to our output A, we can click here on this field, and we can here enter a value. So click here and write, for example, a control value 50%, between 0 and 100%. Afterwards, click here on this right button, the so-called button enter, and then we simulate a control value of 50% at our output on our valve drive output A. So at the moment our output A is not listening to the KNX, he is listening to this maybe here temporary value, and so we override our KNX value. Now you can test, you can send here 10%, 50%, between 100%. And afterwards click here on this cross, and then the output A is still listening to his current value which he receives from KNX. So we can test, for example, here your output A, your thermoelectric valve drive. Then we go here to our output B. Output B, I have set here the parameter. You receive that he receives the control value as a 1 bit. That's why we see here the 1 bit information. I have parameterized it as a heating valve, but I have not activated here the monitoring of the cyclical monitoring of the control value. That's why it is gray. The safety functions are not activated. I have enabled here the purge, but the characteristic curve adjustment is also not used. The output C is also used for thermoelectric valve drive, so you can also check here all your parameter settings, or the safety priority, for example, is activated or not. Output D, at least our output number 4, the same like before. You see here nothing is enabled, nothing. So our fan, which is connected to our outputs E, F and G, the same here. We can see some parameters we have done in our fan. At first here we use it as a multi-level, so as a 3-speed level fan. We can see the status at the moment. The fan is off, fan speed, all 3 LEDs, status LEDs are off. This means the fan stops. Additionally, we see here the mode, like here change over the operation mode of our fan. No forced operation is activated, but the automatic operation now is enabled, and here the red LED is on, which shows that our automatic operation is active. This means our fan coil actuator is listening to the control value which is sent by the room thermostat. And here no limitation at the moment is active. Additionally, I have also enabled a direct operation, and the fan off characteristic, which is not the correct word. The name should be here start up behavior, and here not fan on characteristic. There should be also the run on behavior. But these words are now also overworked in the official release of the new IBUS tool. So now we can send also here a value to our fan, and we can test the fan. So we write here, for example, fan speed number 3, and click here on our button and confirm this value. So at the moment we have now overwritten the value he receives from KNX, and then he goes to our fan speed number 3, and you can see the speed. So, and click here again on the cross, and then he's still listening to the value via KNX. So now when we use, for example, the direct mode, so we send a command go to fan speed number 1 or fan speed number 2 by a push button, then he leaves the automatic mode. That's why here this red LED disappears, and then via a standard switch sensor, rocker 1, rocker 2, we can change direct or manually the speed of the fan. So now when we go back to the automatic mode, then he's still listening to the room thermostat. You will see the red LED now is on, and you see the second LED, the limitation 2, is now active. The limitation can be, for example, additional feature in a hotel room during the night. Now in a limitation we can fix that the speed of the fan can be off, fan speed number 1 or fan speed number 2, but the fan never works in the fan speed number 3 because it's too noisy. So via this LED now we can see that someone has a time switch, for example, has now activated our limitation number 2. The next menu, our output, this is our additional relay. We see at the moment the position of the relay, which is 1. It means we have the relay has been closed. The same here, we are writing a value 0 and press here our enter button. Then we overwrite the 1, and our output H is now listening to this value and opens our relay. You see here the yellow LED. It shows that the object value has been overwritten temporarily by this IBUS tool until we click here our cross, and then he uses the value like before. Let's go to our 3 inputs. The first input, the input A, I parameterize it as a switch sensor. That's why you can see here on the top, A is a switch sensor. We see also here the enabled parameters. So we use, for example, the communication object 1. That's why we can see the green LED. We have also made an internal connection between our input number 1 and our output H. So when we open or close our input A, our relay follows this command internally inside our Fan Coil Actuator. Additionally, I have also enabled the communication object for switching 2, but here, okay, no internal communication. The same principle here, click on this field and enter the value, for example 0, and then we can simulate, for example, the opening of our input, like we open now our standard push button. Press here on the button, and then we override the existing value. So our output B, I have set the parameter you are a value or a forced operation. And now when I open the contact, I send here value 80, and when I close, I send, for example, a value 170. These are the default values I have parameterized in the ETS. The same like here, I enter here the value 1. Click on the enter button, then I overwrite my input values, and the device sends here exactly the value 170 to the KNX. So, and at least our input number C, which is now, for example, parameterized as a PT1000 temperature sensor. You can see here the actual or the current value of the temperature sensor, like here 20.6 degrees. Via additional features, the so-called thresholds, we can send one bit information. So when we enable our threshold, like here the threshold number 1, later you will see we have here also a threshold number 2, we have some values for the upper limit. In the default we set, for example, the threshold for the upper limit are now 25 degrees, and when he exceeds this upper limit, then he should send, for example, a value 1. Additionally, we have here a lower limit of our threshold, which is, for example, 22, and when he falls below this 22 degrees, then he should send a 0 to our KNX bus. And now via entering here value, I can simulate the temperature. So I can write here 28 degrees, press here on the send button, and then you will see that we now exceed our 25 degrees, which is our upper limit, and here the LED becomes red and shows yes, we have more than 25 degrees. Now when I enter here value, for example 12 degrees, then we fall below our lower threshold, which is 22, and you see this LED here becomes also red. So we are these values you can test your thresholds. So, and as a special feature, it is also possible to change here the thresholds. Now via the sliders we can send new threshold values for the upper and for the lower limit to our fan coil actuator. But only when we have enabled that it's possible to do it via KNX. Good, and at the end never forget to click here on this cross, and though the device still listen to the currently measured value. Good. So far you can see what you have seen what you can do here with the IBUS tool. When you have finished your test, then click here on this button back and disconnect the communication between the IBUS tool and our fan coil actuator. And a small additional nice feature you will see here in this menu, recently used devices. You can see here the 1150 and the short description FCAS. So you can, the next time you can directly click here on this address and click on the button connect, and you have not to enter here manually again the individual address of a device. Good, so far the IBUS tool. Some more informations about marketing. All marketing material, like for example the product manual, wiring diagram, or also the technical handbook, all these specification text are now available on our website now today, but only in the German and English language. The other languages will follow soon. So visit our website abb.com/knx, go to the product categories, heating and cooling, and then go to the individual device of our new 4 fan coil actuators. So additionally, we have still existing documentation of heating and cooling. One is here our PDF file about heating and air conditioning and ventilation with EIB. You will see this is a little bit older brochure, but the principle or how the system works is still up to date, but only you will see former devices are inside. So, and our application manual, special brochure for heating and cooling, heating, ventilation, air conditioning, you remember, is also available as a PDF on our website. And at least we have some e-learning modules. E-learning modules are kind of animated PowerPoint presentations in German and English language for DALI light controller, security, and of course an e-learning module about room climate control. So it's also available on our website. Let me show you information of our next webinar. The next webinar will take place on the 27th of May in 4 weeks. The topic now is the application unit ABLS, ABZ and logic modules. So we will introduce you these existing devices, what you can do with the ABL, the gates, the inputs, the outputs, the logical operations, how to fill the telegrams, and of course some solutions. When you need an ABL, for example, for separation wall solutions or to convert a 1-bit into an 8-bit telegram and so on. So you will also receive an invitation email, but remember the date. So in 4 weeks at the same time, German time, 9 o'clock in the morning and 3 o'clock in the afternoon. So far, I think this brings us to the end of the webinar. Thank you for taking part on this webinar. We will see you back in 4 weeks for our next webinar, application unit and so on, logic module. Thank you for taking part. Have a nice day and goodbye to all. Goodbye.
Bye bye. Ciao.